In this video, let's talk about a pulley. Now, what is a pulley? Now, to a layman, let's not waste our time. To a layman, a pulley is just like a weightlifting machine. At this point, just watch the picture on your screen. Now, watch out. If you've seen the picture, you should understand that the man is trying to raise a heavy object up. Does it make sense? Now, understand that this is very simple and is applicable in real life. Now, watch out. I have you on the floor from what you've seen. I have you on the floor. You are 100 kilogram. Does it make sense? And now to raise you up, it makes no sense for me to carry you from the floor. And for me to do the work in an easier manner, what do? I attach a rope on you. Does it make sense? Now pass you through your what? Then I pass the rope through a wheel. Now through the wheel has a groove. Now through the wheel, and now drag the what? The rope down. Now you should understand that when I'm trying to drag the rope down, that you are moving up. The idea is that for you to be a pulley, the idea is that you are a weightlifting machine. From the picture you've seen on your screen, understand that the man is trying to raise an object up. Now to raise you up, carrying you from the ground will be very difficult. Now why don't we attach a rope here? If you attach a rope, I mean one rope, attach the rope, pass the rope through a wheel. You are a pulley, you are a wheel, and you have a groove. Now through the wheel, now you now drag the rope down. As you are dragging the rope down, what's happening here? You are moving up. Does it make sense? So by now I've explained what a pulley is. A pulley is a weightlifting what? Machine. Now class, the aim of this video is to resolve forces. To resolve forces that acting on what object that has been lifted up, and the force actually here. Now watch out. Look at what I'm trying to say. I have a pulley. I have a mass called here M what 2. I have another mass. I have another mass here called who M what 1. Try and understand what I'm trying to say. Now, as far as we are in air, now watch out this. We have two masses. Now, the idea is that mass 2 is greater than mass 1. For the fact that mass 2 is greater than mass 1, and both of them are connected with the same rope, understand that mass 2 will be the one moving down. And as mass 2 is moving down, mass 1 is doing what? Going up. Now, try as much as possible to see mass 2 as a man dragging down. But as you are seeing mass 2 as a man dragging down, you should not see mass 2 as a person. See mass 2 as a heavier object, as a person trying to lift mass 1 up. Does it make sense? Now understand that these two masses are in air. Now since you are in air and you are a rope, since as you are a rope and there is movement here, one person is moving the other. There is tension on this rope, we call you T1, and there is tension on this rope, we call you T2. Understand that these two tensions are acting up, but the direction of the motion is what? To the one, to the weight of M2. Now understand that since you are in air, that your weight W1 will act downwards, and since you are as you are a mass and you're also in air, your weight will still be what? Acting what? Downwards. Does it make sense? Now, what am I trying to say? Let's resolve the forces. Now, watch out very well. For mass 1, please, watch out very well. For mass 1, what is happening? The force is acting on mass 1 is the tension on the rope that is acting upward, and the weight of mass 1 that is doing what? Acting downward. Now, what did we say? We said that mass 1 is the person trying to what? Go up. Now, since mass 1 is going up, it means that the force acting up is bigger than the force acting down. What I'm trying to say is that the tension on mass 1 is greater than the weight of mass 1. Understand it. If you've not watched my video on weight of an object in a lift, try as much as possible. Go back there. This is very simple. Now, for mass 2, what are we saying? Since mass 2 is the person dragging mass 1 up, since mass 2 is going downwards, and I have two forces acting on mass 2. The first force is the tension on the rope, and the second force is the weight of mass 2. Now, it means that since you are moving downward, the person leading the motion is your weight, and the person that is lagging behind is the tension on you. Now, it means that for mass 2, I'm trying to say that the weight of mass 2 is greater than the tension on the rope on mass 2. Does it make sense? Now, what I'm trying to say at this point, since you are tension and you are in force, since you are weight and you are in force, it means that since you are greater than this person, and when I take your subtraction, that tension 1 minus weight of body 1 is equals to another force. Now let's call it MA. I should have written F here, but since F is also a force, we should call it what? Mass and acceleration, because the formula is mass and acceleration. Now what I'm trying to write again is that T1 is T1 minus W1. Who is W1? Is mass 1 times acceleration due to gravity. Does it make sense? The weight of mass 1 is the mass of mass 1 times this acceleration due to gravity. Does it make sense? Is equals to mass times acceleration. That's m1a. Should understand this at this point. Now I have that tension 1 is equals to m1a plus m1g. That's trying to make tension 1 subject to formula. Now we are done with mass 1. Let's go to mass 2. Now, since the weight of mass 2 is bigger than the tension on the rope on mass 2, it means that when I take the difference, W2 minus T2, it should give me another force because both of you are what? Are forces. Now, the subtraction should give me a force, and a force is mass times acceleration. Now, the weight of mass of the body too is what? M2 what? G. Do you understand that weight is mass times acceleration due to gravity minus what? T2 is equals to M2A. I hope you understand at this point. Now, if I try to make T2 subject of formula, what am I going to do? I have to move my minus T2 over, and when my minus T2 crosses the quality sign, it changes to T2, and M2A has to come over here. It becomes minus M2A. So what am I trying to say in essence? That the formula of T2 is equals to what? M2G minus who? M2A. Now, I want to tell you something. I should not play with it. Since these two masses are connected with one rope, I repeat, since both of you are connected with one rope, what are we trying to say? That the tension on the rope, the tension here and the tension here is equal. The tension here and the tension here, both of them are equal. In physics, when you are talking about one rope, two objects connected with one rope, the two tensions are equal. But in a situation when we are having two ropes, two different ropes, the two tensions are never equal. But now, since understand that this is a wheel, that you passed a rope here, they are talking about one rope. Since you guys are one, since this is just one rope, the tension on mass 1 on the rope beside mass 1 and the tension on this rope beside one mass 2, they are what? The same. So what we are trying to say is that T1 is equals to what? T2. Since T1 is equals to T2, who is T1? T1 is M1A plus M1G is equals to who is T2? T2 is M2G minus who? M2 what? A. Try as much as possible to make those ones having A to be on the same side. In other words, let's collect like terms. What we are trying to say is M1A, making a minus M2A to come over here, we have plus who? M2 what? A is equals to, then plus M1G, go over there, I have M2G minus who? M1G. Now watch out. Acceleration is here, acceleration is here. Factorize. I have A into bracket M1 plus who? M2 is equals to who? M2G minus who? M1 what? G. Making acceleration for subject of formula, I will divide both sides by M1 plus who? M2 all over who? M1 plus who? M2. I will cancel here, cancel here. So finally, the formula of acceleration of this system is equals to what? M2G minus who? M1G all over who? M1 plus what? M2. You see this formula that I have over here? You don't play with it. This formula that I have over here, you don't play with it. And I'm going to tell you something. They might ask you, what is the acceleration of the mass 1? What is the acceleration of mass 2? Understand that when I'm having one rope in physics, that the tension on the rope, T1 and T2 are equal. I should tell you that if you are considering acceleration of mass 1 and call it A1, and the acceleration of what? Mass 2 and call it A2, the acceleration is still what? The same. As far as I'm talking about one rope, the tension T1 is equals to T2. The A1 is equals to what? A2. The system have what? The same what? Acceleration. And the tension on the rope for the two masses is still the same thing. You don't what? Panic when they say calculate the acceleration of mass 2 or calculate the acceleration of mass 1. You don't panic when they say calculate the tension on the rope beside mass 1. Understand that when we have one rope, when the two objects are connected with one rope, that the tension T1 and T2 are equal, and whatever you call it, A1 and A2, still that what? Equal. It becomes something different when you have what? Two rows. I hope by now you understand it. You don't play with this formula. You don't play with this formula. And when they ask you a question, you should understand that you have to get acceleration first. And when you get acceleration, if they say find the tension, you can come here, input the acceleration you get here, you get the tension. Or you can take the acceleration, input here, you get the tension. Understand that whatever you get here will be equal to whatever you get here, because we've been already saying it that T1 is equal to what? T2. Have a nice day. Like, comment, share, and follow Courses Academy. Bye-bye.